Hi and welcome back to a new video. Today on my table I got an MSI GT77 12U, which means that it's using 12th gen Intel. Typically when I get those kind of like review requests or like offerings to test a notebook, I most of the time decline it. But with this I thought, wait, so this has a 12900HX in there, and HX means that it has an unlocked multiplier. And then I thought, wouldn't it be interesting to see if we can set a new frequency record for notebooks using Alder Lake? Because Alder Lake is quite easy when it comes to high frequencies. That's what we already know from all the desktop CPUs. And especially notebook CPUs typically have very high quality when it comes to leakage and to the voltage required for high clocks. So I think this could theoretically be possible. Typically, if you would do this on a notebook, then you're all the time cooling limited. So even having a 12900HX in there is usually not going to give you much because it's still limited to cooling. But I think we will just make our own cooler and then maybe dry ice or liquid nitrogen and see how far we can get. From my quick research online, I could find an H950HK, which is a few generations older, and this CPU was clocked to 5.5 gigahertz. All the other CPUs back then, like 11980HK or like 10900HK and all these CPUs, the HK CPUs I checked, and the highest I could find was from the 8950HK. And we will try to beat this. This video is sponsored by Hetzner and their dedicated root servers. The AX line offers a wide range of servers depending on your required CPU power, storage and memory. It starts with the AX41, which features a Ryzen 5 3600 with 64GB of memory and two 512GB NVMe SSDs. The AX101 would come with 5950X, 128GB of ECC memory, and two 3.84TB NVMe SSDs, of course fully configurable with the OS you need, additional storage and gigabit connection. Find out more in the link below. Of course, to get anywhere with overclocking on notebooks, you need access to settings. And that's why I love MSI notebooks, because on most of them, that's also public information. If you press right control, right shift, left alt and F2, you can get this advanced submenu. For example, CPU configuration, you can get all kind of access to like power tables, to CPU multipliers. So you can set everything you want, like power performance, as I said before. You can get access to the turbo tables, you can set the power limits, different states if you want to. But for us, the most important option would be overclocking performance menu. Then if we scroll down to processor, then you can find the most important what we need. If you really want to overclock this CPU for frequency, we have the P-core voltage offset, which you can easily set just right out of the BIOS. The overclocking itself will be done using Intel XTU. You get all the access you need. I still have to disable most of the power saving features, which you can see if you just right click in CPU-C. The cores are still happily doing whatever they want. But I'm already running a static voltage of about 1.25 volt, and you can see in XTU I can also apply the multipliers. So setting all of them to a minimum of 49. So that also works. Still have to get rid of all the power saving features, but that's something we want to do when we have the cooling ready. But to get our very specific cooling method, I want to replace the CPU and maybe the GPU heatsink. It will depend how it's built internally. For that, we will just open it up and check how it's built. Then I will be able to measure everything and do the CAD work. Now just look at this. Like, how insane is this? We have 4 M.2 drives in here that are like fully populated. We have 4 SO-DIMM slots in here that are also fully populated. That means this should be 64GB of capacity inside a notebook. Then we have this massive cooling thing on top right here. Unfortunately, at least for our purpose, I think everything is somehow connected with each other. So this is the CPU, this is the GPU area. You can see from the CPU there is a tiny heat pipe going all the way to the left. And for example, from the GPU there is a bigger one also going to the right. So everything is like kind of connected, which absolutely makes sense for the normal operation, because you want to utilize the entire heatsink for every operation. Even if you just use the CPU, you also want to utilize the left part of the heatsink. So that makes absolute sense. But for us, it means we will also have to build a heatsink or like a cooler somehow for the GPU. Now without heatsink, I left most of the fans in there, especially this one. There's like a cable attached, but that should not matter. But right now, yeah, I will spend some time thinking about how I can realize and optimize the cooling. I did some measurements last night and also a little bit of CAD work. And I decided to take one of these samples. We made some of those like tiny liquid nitrogen containers for a different project, but there was a single one where we did a little bit of an oopsie on the laser engravement, so we will just reuse that one for the notebook cooler. So yesterday in the evening I spent some time just doing this, a little bit of CAD for the backside of our container. That will be the contact surface for the CPU, a little frame around that should just lay on top of the PCB for a little bit of easier handling. And yeah, we'll see if that works out. Easy. Looks like the small container is ready to go. I just hope it will fit the way I thought it would. To figure out if our cooling block will just fit fine, just doing a little mounting test with thermal paste. Yeah, that looks pretty much perfect, so yeah. Definitely very nice contact. In addition, I put some insulation tape like Kapton tape around the GPU and also the CPU area just for some very basic protection. If you would run this like seriously for more than, let's say, 1 or 2 hours, you would probably have to take out the entire motherboard out of the like notebook case, insulate it properly, and then you should be good to go for a longer time period. But yeah, like for a first try, I think this should just work fine. The GPU container is already in place, it's just sitting on there. For the CPU container it's a little bit more difficult because of the cutouts, I have to really carefully place it. Some dry ice pellets. We will run an extremely professional setup. Once again, the thing was that even though I'm using an external keyboard, I still have to be able to access the power button. That's why I had to place the notebook in between those two boxes to be able to access the power button in case something fails. I just hope it won't fail as often. Okay. Here we go. That's already a very good start. I was trying to enter the BIOS. I was hammering delete, 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 and I was like, why is it not entering the BIOS? Turns out it did enter the BIOS. The thing is, I just have to use this monitor. Great. It's not as easy as I thought. There are some things going on in the background, something with the power settings. Even though I disabled everything like seed states and everything you can disable, it still happens that after being in Windows for like 5 to 10 minutes, suddenly the clocks drop. Like even if I don't even touch anything, like right now it's a static OC. It's like running 4.9 on all the clocks, nothing moves, and then suddenly after a few minutes it goes down to like 1.2 gigahertz. I'm not quite sure what's causing this, but even if I have only like 5 minutes, it should be sufficient that if we enter Windows, ramp up the clocks, go down in temperature, that's what we're going to do now, should be able to achieve some higher clocks, because right now I'm still in the area of condensation on the container. Because you can maybe see there's a bit of water on there because it's only like +2, +3 degrees Celsius. That's why I will now pour some acetone into the containers to increase the surface area and the contact between the dry ice and the container. And this way we're maybe getting to like -50, and that should definitely give us better temps. We are already at roughly 5.6 gigahertz on all of the P cores. I already validated the clock as far as I can tell. You can see the validation file right here. So that should already be the highest clock so far as I know, achieved on the notebook. The max we were able to show was 5.8. If it crashes at this temperature, it's definitely always a challenge to get it back up and running, at least on notebooks, because there are several things that are definitely not tuned for XOC, but it seems like this notebook is somehow made for XOC. You can see it's easily going back to Windows. For the current overclock, we were also only using a core voltage of 1.3 volt, even though it's showing core VID of 1.44. But I will now try to increase it to maybe like 1.45. This will maybe give us a bit more headroom for additional clocks, at least like static clocks. So with a little bit more voltage, 5.7 seems to be at least semi-stable. And 5.8 seemed to be too much. So far, even after a bit more than 1 hour, is still going strong, and only a bit of condensation, bit of like ice left and right. The only concern I had was that I was putting the container a bit onto one of the DIMMs on here, but it seems to take it quite well. One thing I want to try now is the CPU profile benchmark, which is like the new CPU test inside the 3D Mark bench. So for whatever reason, it's quite a bit slower than I expected. Few hours later, I have a ton of problems. I have no idea what's going on. Right now, I just cannot apply any settings anymore. So whatever I set to the core, whatever I set to like the, I don't know, frequency, B clock, voltages, nothing is getting applied anymore, and I have no idea what's going on. So at this point, I will just have to stop and probably try again. And of course, after trying for much longer than I actually intended, there's a lot of ice that built up, which means that I will have to clean and dry everything like really properly, otherwise might break it. 4 days later, and a lot of time that I lost later. The thing is, when we ended our session, I ended up having a ton of problems, and at this point I was not sure if this is caused by like condensation, like running the thing cold. There are always some factors that could lead into problems. That's why I was not sure if it's just due to the extreme overclocking. So just going back in time, for you it's a few minutes. When I was doing the first overclocking, everything went fine. We were able to push the CPU to 5.7. Then I was trying to do some multi-threaded benchmarks, and I saw that the CPU could not sustain the clock. So when I was running like 5.4, 5.5 gigahertz, it could hold the clock for maybe 10, 12 seconds, and then it would clock down to sometimes even like 1.6 gigahertz. So something was kind of wrong. I didn't know exactly what. I was trying to investigate like power targets, different things, then narrowed it down that it didn't like higher voltage, and running a lower voltage could keep the clock more stable, but not stable enough. So it crashed in between, and then after trying several things, this happened. And then this kept going for about 15 minutes. Even though this device was not connected to the internet, Microsoft decided that it's a good idea to have some Windows update loaded to the MSI notebooks. And then after this, nothing worked anymore. Like I couldn't apply a single setting out of BIOS. Like whatever I tried, nothing was applied. And when I was entering Windows, XTU told me that overclocking is disabled on this device, which just doesn't make any sense, because you could see that we just earlier did like very successful overclocking. 5.7 multi-threaded on a notebook, as far as I know, was the highest ever achieved. So that's already a great success. But we also wanted to do some multi-core benchmarks, which didn't work out. And then XTU tells me that it's not possible for overclock. I also double-checked with throttle stop and also double-checked with an Intel internal tool, which also didn't allow me to touch the CPU, which is quite obscure. Then I contacted Intel because I heard rumors when also doing some investigation that theoretically you could get a microcode update into your CPU via a Windows update. But then Intel assured me, and also MSI, that currently there are no other microcodes than the release one for this specific CPU, so it didn't make any sense. Then MSI did a little bit more investigation, and they finally sent me a new BIOS, which maybe now helps me to get XTU back working, because no matter what I tried, like full EC reset, everything, like nothing helped. And I spent, I think, more than 10 or 12 hours literally testing every single option that exists in the advanced BIOS. I mean, even though it was like easily working on first attempt. Let's see what a BIOS update brings. Unfortunately, with the new BIOS, it is still exactly the same. Even though if I go to system information, it tells me that turbo overclockable, it says true. However, if I go to advanced tuning, or first we can go to speed optimizer, here it already tells me that overclocking is disabled on the system. And in advanced tuning, I only have access to some of the turbo features, such as the time window or like the ICC max, so the current of the CPU. But like all the other options, as you can see, like the core tuning, everything is completely disabled. Again, about 4 or 5 days later, it was a quite annoying thing, but I had very good support from MSI. So MSI, thank you very much for your help. And we narrowed it down what the actual problem was, and it was indeed related to the Windows update. So when this thing did this automated Windows update, it did flash the BIOS, but without a microcode update. But it did a normal BIOS update to some kind of newer version. And probably because it was not stable, because it was running like 5.7 gigahertz at this moment, it probably crashed during the BIOS update, or at least something went wrong. And because something went wrong, I couldn't adjust anything anymore. So now flashed to a new version, flashed again back to the older version, and now we are back and we can adjust things. And I think we are on a very good way to get a new record for the 3D Mark CPU profile benchmark. Right now I just did the first test with max threads to just see what kind of performance we can get. The current record is 11,300. We have 11,600, but now I have to complete the full test and not only the one sub-test. But I'm pretty sure this will just work fine. It's not even clocked high, it's like 5 gigahertz, because there also seems to be, I'm not sure if it's like power related, but whenever you push the voltage too high on this CPU, it starts throttling, even though it's not reaching the power limit, it's not reaching the temperature limit, but whenever there is a too high voltage applied to the CPU, it starts throttling. And now I'm trying to find the sweet spot for the highest voltage possible and also the highest clock possible without exceeding our thermal possibilities we have here right now. Finally getting somewhere. CPU is now running stable at 5.3 gigahertz across all of the cores. 5.3 might not sound that impressive, but in the end it's still a notebook, and yeah, I think that's still quite nice. Load-wise, we are exceeding 200 watt. It's a 230 watt PSU if I remember correctly, so I'm not quite sure when we are hitting the limit of the PSU as well. But 12,200 points, that is almost 1,000 points higher than the previous record, so finally a bit satisfied. Next up, I want to try 3D Mark Time Spy. That's why I'm just cooling down the GPU part, and you can hear the dice pellets screaming inside the container. The CPU part is still quite cold, it's like minus 63, but yeah, whenever this reaches the same kind of region like minus 60, it will finally stop screaming as well. After I completed the first Time Spy run, I was like, why is the score so low? That's a typical thing you have while benching. But then I figured out that compared to what is listed online, this is a real notebook GPU, right? It's a 3080 Ti notebook. But the results online also include like a 3090 Ti, which is connected over Thunderbolt, like an external GPU dock, which means that it will be impossible to compete against like an external dock with a proper GPU. So we will just run some Cinebench R20 instead. In the end, I was able to achieve a score of about 11,000 points in R20, which for a desktop system doesn't sound that much, but for a notebook, it definitely is. The highest score I could find with an Intel air-cooled notebook CPU was about 8,500 points, so that's definitely a huge jump. But then also you have to consider there are also AMD desktop CPU versions floating around, like the XMG notebooks where you have the AMD desktop CPU sitting inside a notebook. To beat those will be probably quite difficult. But then again, my main goal was to achieve the highest frequency ever in a notebook, which I think we did, as far as I know. So 5.7 on all the cores. So that I think already is a good achievement. Then CPU profile benchmark, we improved the score to about 12,300 points, which is about 10% more than the previous record on 3D Mark website. So very satisfied. Overall, it was a good journey. It was ups and downs. I had a lot of fun, like first of all, preparing the cooler and everything, but then also having a lot of issues with the automated BIOS update we had and everything, but you just have to stay on it and then you can achieve something. And I think it was quite nice in the end. I guess that is a perfect point to stop with this video because the GPU container just lost the ice and everything melted, which means that it might start to drip down onto the board. And Intel, if you're seeing this, thank you very much for providing the notebook, even though I didn't tell you what I was going to do with it. If you're seeing this, yeah, actually I'm not sorry, but thank you for watching. Bye bye.